Hello, good afternoon, welcome. This is psychogeometry question. Let's have a look at it. A, B, and C are points on the circle center O. DE is a tangent to the circle at C. AC equals 10 centimeter. AB equals 9.5 centimeter. And BC equals 7.7 centimeter. A, show that angle ABC equals 70.2 degree, correct to 1 decimal place. B, find Roman figure 1 angle AOC. Roman figure 2 angle ACO. Roman figure 3 angle ACD. C, calculate the radius OC of the circle. D, calculate the area of triangle ABC as a percentage of the area of the circle. Let's look at the solution together. The solution. To show that the angle ABC is equals to 70.2 degree, correct to 1 decimal place in the diagram, we need to apply the cosine rule. Looking at the triangle, look at this triangle, ABC. The three sides of the triangle is given and no angle of the triangle is given. So the rule that will help us to solve for the value of angle at B is the cosine rule. So the cosine rule will say B squared is equals to A squared plus C squared minus 2AC cos B. That means 10 squared is equals to 7.7 squared plus 9.5 squared minus 2 times 7.7 times 9.5 multiplied by cos B. So making the unknown the subject of the formula, which is cos B, cosine B is equals to 10 squared minus 7.7 squared minus 9.5 squared divided by minus 2 times 7.7 times 9.5. So cos B equals 100 minus 59.29 minus 90.25 divided by negative 146.3. So the cos B is 49.54 divided by 146.3 because the signs will cancel out. So cos B is equals to 0.3386. So to find the value of the angle at B is equal to the arc cos or the cos inverse of 0.3386. Therefore B is 70.2 degree. That shows correct. We are able to prove that the angle ABC is equal to 70.2 degree. That is a part of trigonometry. Now, in trying to solve question B, it says calculate the angle AOC. It is expected that the students will observe the diagram very well. The O is the center of the circle. And the angle available to us, the angle B, is an angle on the circumference. The angle on the circumference. If you are familiar with psychogeometry, there is a rule which states that the angle at the center is twice that which it subtends at any point on the remaining part of the circumference. Let me take it again. The angle which an arc of a circle subtends at the center is twice that which the same circle subtends at any point on the remaining part of the circumference. What am I trying to say? Look at the chord AC. The chord AC subtends an angle at the center marked O, and the same chord AC subtends an angle at the circumference marked B. These two angles are related. That means 2 times angle at B equals the angle at O. In other words, coming back to the solution, the angle AOC is equals to 2 times 70.2 degree, which is 140.4 degree. That is the angle AOC. To calculate angle ACO, we consider the isosceles triangle in the diagram. There is an isosceles triangle in the diagram. The triangle AOC is an isosceles triangle. What is an isosceles triangle? A triangle with the two sides equal and the base angles are also equal. So we have AO equals to OC. Since the angle at O is 140.4 degree, we say, coming back to the solution, 180 minus 140.4 divided by 2 or multiplied by half, which is 39.6 degree multiplied by half, which is 19.8 degree. 19.8 degree is the angle ACO. Now we need to find the angle ACD. ACD. The angle ACD is the angle between the tangent DCE and AC. So the angle ACD, is equal to 70.2 degree. The reason is simple: alternate segment. Alternate segment. That is, the angle between a chord and a tangent is equal to the angle which the same chord subtends in the opposite segment. So the angle ACD is equals to 70.2 degree. The angle ACD is equal to 70.2 degree. Let me take it again. The angle ACD is equal to the angle ABC. That is, the angle between a tangent and a chord is equal to the angle the same chord subtends in the opposite segment. A chord is a line that divides a circle into two segments. The segments may be equal, and when that happens, we call the chord diameter. But if the segments are not equal, we simply address it as a chord. And in that case, the bigger part is called the major segment. The smaller part is called the minor segment. So the angle ADC is 70.2 degree. The reason is alternate segment. But to find the angle ACB, we apply the cosine rule. The angle ACB, we are applying the cosine rule. We are applying the cosine rule to find the angle ACB, which you can see the angle ACB is given as 63.4 degree. Now to find the area of the length of the radius To calculate the radius, we use the length of the chord. And the length of the chord is given by 2r sine of theta over 2, where theta is the angle at the center, the angle at O. So the chord used is 10 centimeter, that is AC, which is 2 times radius sine of the angle at the center, which is 140 degree over 2. In that case, we have 2r sine of this over this. So we have 10 is equals to r sine 70.2. So we have r is equals to 10 over 2 over sine 70.2. So we have the radius. If you look at the solution, the radius is 5.314 centimeter. So area of the triangle ABC, we use the formula. Have AB sine C, or have BC sine A, or have AC sine B. So having used the angle, have AB sine C, that means half times 7.7 times 10 sine 63.4 degree. So which gives us the area of the triangle as 34.42 centimeters square. And area of the circle is always pi r squared, which is 3.142 times 5.314 squared, which gives us 88.73 centimeters square. So percentage of area of the triangle to the circle is given by area of the circle over the area of the triangle over the area of the circle times 100 over 1. That gives us 38.79%. Thank you for being part of our class today. I still remain my humble self, Mr. Okeke Emmanuel Ogemde. If you have a question, please do wait to drop it at the comment section. If you wish to hear from us directly, you can get us through our number 080-387-46884. Thank you for giving us your time. If you do come across our video on Facebook or YouTube or WhatsApp, please do where to share. God bless you.